Hey everybody, thanks for showing up this morning. I don't know why, but I was looking earlier, right before we had everybody here, and it looked kind of like a Southwest airplane where everyone's against the wall / window or along the aisle. But it all works now. So I'm glad you guys are here, and hopefully we'll get some good discussions and conversations and learn some stuff over the next 50 minutes or so. We're going to talk about your software supply chain. Does anyone here work in that specific field now, or just interested? So a few of you, okay. Sounds good. Let's go ahead and dive in. So who am I first? So I work for the Fortify team. If you guys, maybe many of you guys have probably heard of Fortify. At one time, it was a software company that did been in the software security space for 14 or so years or something like that. So I've been with them for a little over 10 years, and then through mergers and acquisitions, I've moved to various other new companies like Hewlett-Packard and Micro Focus, and on we go. But same job, same role from the start. There's a solutions architect / pre-sales engineer involved in the sale of software security testing and analysis and management type of software to keep your software applications clean. I had some other jobs in the past you can see listed up there, but I've been with this one long enough that I feel like that's who I am. Okay, I'm not going to read through this slide, but just suffice it to say, what I'm going to talk about here is not, it's not like, okay, here's how you build your software supply chain risk management capabilities, right? I'm not going to do like building blocks and here's what best practices or whatever. This is more based around the trends that I've seen within the space and then drilling into some of those. So it's not going to be as comprehensive maybe as some. I don't get deep into compliance and policy and things like that. But I do talk about what the bad guys are doing and what the good guys are doing in response from a kind of a trends and what's going on recently perspective. This is a relatively new space within the software, and it does fit kind of nicely within application security as well. So we're going to talk through some of these that you see up on the screen now. So diving straight in, so 97% of companies have had a cybersecurity breach because of weaknesses in their supply chain. So this is a real problem, a real big problem with this. This stat's only 2 years old, and I doubt it's gotten better. I do have some more recent ones a little bit further down, but that's at a high level what we're fighting against. So when we talk about the software security chain, what are we really talking about? Right, so this is the supply chain is everything that goes into your software. So even if you have a development community or a set of developers, or you work for maybe an organization that creates commercial software, so you have a series of people that are building that software for you. There's a lot that goes into that. It's not just from their head through their hands into the keyboard to program things and create source code that then compiles into something that's useful. There's a lot of other pieces in there, and that all makes up your software supply chain. So it boils down to the question up top: what goes into your software? Like, where did all those pieces come from? Do you have open source objects? Do you have commercially created objects? Are you using frameworks that maybe the old contractor used and you inherited when you won that business from the government? Or whomever. Are there other pieces and libraries, even hardware things potentially that that tie into your software, and that do you know where it came from? Do you know the history of it? Do you know who touched their hands on it? Et cetera, et cetera. So that's what this kind of managing or understanding your software supply chain kind of boils down to in a simplistic manner. With the goal is to understand everything and understand the impact it has on you from a security and a licensing perspective. Actually, this isn't too big of a room, so we can try if anyone has any questions as we go along. Raise your hand, we can fire those off. If we start to lose too much time, then we'll switch back. We're going to talk about the executive order. This is the big one that happened recently in May of 2021. So I talk about that a little bit further down, but the last bullet point is around the executive order that came down through President Biden that really starts to address securing your software security, or your software supply chain, excuse me. Okay, so this is a good kind of the state of the industry around software supply chain. So this is publicly available on the internet. This is an organization called Sonatype, who's heavy into some of the capabilities in and around understanding and securing your supply chain. But we have some stats up here that has come out of there. They produce this report, I think, every year, actually. So it's, again, you can go find it at Sonatype's website. Unfortunately, my screen is so small. Okay, so I'll read these since it's probably small on your screen too. So 1 in 8 open source objects that organizations are using have a known risk in them. So people are taking objects that are out there that are usually in like a public repo, or pulling them off of various other download Git sites and things like that. And they're pulling down versions of that particular software where we as a community already know there's problems with those. So that's happening 1 in 8 times, which is obviously a little bit too much. So in the last year, 245,000 malicious packages have been discovered. 18% of open source projects across Java and JavaScript that were maintained in 2022 are no longer maintained. So that means we have a lot of objects out there, almost 1 in 5 that organizations are using that are no longer being maintained, fixed, patched, and fixed, particularly if there's some kind of an incident and there's not even anyone to responsibly report it to necessarily. So that's a big problem, and you need to understand if you have those, what is the maintainability and the support that you're getting with the objects in your guys' source code is a big question there. 96% of vulnerabilities downloaded releases had a fixed version available. So that kind of fit into one of the stats up above, where even though we know, say, Log4j, which we get a little bit into very shortly here, that there was a problem there, a big problem a couple of Decembers ago, organizations are still pulling down older versions of those that have the flaw in them. Up to 96% actually. And then the last one I'll hit on this slide is 10 superior versions of components are typically available. So as organizations are pulling down older versions of libraries and frameworks and whatnot like that, there's up to 10 versions beyond that usually that are available that have one or more fixes or one or more license modifications or something that makes those better. And that's just not making it down to your development organization. They're just pulling things, and it's kind of the Wild West out there if you just allow everyone to pull from what's up on the public internet. So those are some of the challenges and the problems. To come at it from a slightly different, here's a few more problems before we start to get into the solutions and things. The trends that we're seeing over the last 10 years around the software supply chain are state actors getting involved. That's not surprising for anyone involved in any kind of security. The malicious or not so friendly countries have, are really taking an eye on this and taking a part in what's going on within the securing your supply chain and in just security in general. On the right side, I listed a bunch of vulnerabilities or hacks or some stuff that happen within a supply chain, not with the intention of reading through them or anything like that, but just to show that this problem is just getting bigger and bigger and bigger. And as I said before, I do drill into a few of these in just a few minutes. Organizations are getting better and more sophisticated at hijacking or taking over parts of the source code and getting those blasted out to unknowing users of those particular software or software libraries. There's a code signing. So we use code signing as a kind of a defense against a lot of things, right? I mean, are you downloading the actual valid version of the latest release of ABC's enterprise software, right? So you can check the hash or check the signing of the certificate and make sure that is in fact okay. So the bad guys, the black hats in this case, are finding ways to undermine that or take advantage of that or precede that. And we have a couple examples of those coming up. They're attacking open source repos and open source libraries, open source applications directly, because those are being used more and more and more in development. And let's just, a couple more. So App Store attacks, so putting something up on the App Store that's in fact malicious, but it looks benign. It looks like the real deal. Oh, this is actually an early version of this I heard was a flashlight application before all your phones had flashlights, that like pulled people's contact lists and sent them off, but it was supposed to just be a flashlight. Those are easy to catch now, but they're getting more sophisticated about getting through those defenses. So they get malicious software into that App Store. And then they're using credentials. That's already been touched on a bit. Is stealing credentials, someone using those in order to corrupt the supply chain. And then, as we'll see as we get into some of the detail here, that a lot of these attacks are not taking advantage of a single vulnerability. They're kind of multi-stage. So we find a vulnerability, we can get into the repo, then what do we do with that? We can change this so that it looks like it's still legit, but it's really not, and then that winds up getting downloaded by 50 people, and then the exploit hits there. So it's not simple, oh, I found a vulnerability, let me exploit it. There's multi-tiered, multifaceted attacks going on now. This one I'm not going to spend a lot of time. This one just shows that it's obviously fairly unreadable anyway, but you guys, I think you know these slides are going to be made available to everybody, so no problem. So you can read through these if you really wanted to. But this is just showing the backdrop here is a development, or it's just software life cycle going on here. Design, develop, deploy, test, maintain, improve, et cetera. And sprinkled on top of that backdrop here with the arrows and the various phases of the life cycle are various supply chain attacks that have occurred within the last few years. So the point being that the entire supply chain, the entire development life cycle is in the same or sometimes different ways vulnerable to these types of techniques and this type of attack vector. So let's take a look at some specific ones that have happened over the last couple years or even months in some of these cases. So log4shell, or the log4j problem. Who heard about this one? Yeah, should be a lot of you. So log4j was the actual attack, or the actual open source product that was attacked here. The name of the exploit is log4shell because it allowed the attacker to pop a shell up and do what they needed to on top of the server where that particular library is running. So just a quick backup. So log4j is a Java package that does logging. So if anyone develops software and they needed to have a logger as a piece of what they're doing in their software, most people aren't going to write that from scratch. There's dozens of options out there. You take an open source or a commercial product, use that to do your logging for you, and you save yourself hours and hours of work. Pretty simple. So what happened here is somebody figured out an exploit where they're using the Java naming and directory interface. So in other words, when a page loads and it starts to pull information from the server and it's showing up in your browser, sometimes a piece of the page that comes down says, okay, go connect to this other server and pull some more information down. Like maybe you have a stock ticker or something on your thing. You're going to go pull that from a third-party site and post that widget up on your web page. So it's a perfectly valid thing to do, is to pull information from other servers that are happening. So this exploit, it made it so that if you could plant those remote calls into the logger, and when the logger fired off certain commands and functions, then that remote pull would go out to a server and pull information back just like it's supposed to work. But in this case, the attackers had control over where that went. So there's a malicious server in this case, so they went there, pull that stuff back, and then execute it on the server, and that's where the exploit hits. I think most people here are probably familiar that when it comes to a software or a supply chain on your software attack, usually the holy grail is to be able to execute something, preferably with some privileges on whatever the target machine is. So in this case, they were getting their code to exercise on your server to do nasty things. So in most cases, they're doing something like stealing valuable information, or et cetera, off of those servers. We also call this remote code execution from a vulnerability standpoint. Same kind of thing. I'm going to get what I want to run on your server. This one's interesting because it spawned a bunch of CVEs. CVEs are known vulnerabilities that are out there within certain packages and things. With the concept being that we fix these and then they can go away. But this one actually had to get patched about 3 or 4 times before they actually patched it completely. They're obviously in a race against time because this is the most popular logging framework in the world. So it was everywhere. So the open source folks were trying to fix it as fast as they could, and they had problems getting it fixed. So it took a few tries. But luckily, it still happened relatively quickly. Okay, this one's kind of an interesting one. Magento, or what is called the Magento. So there's an application module that's used for very popular within e-commerce. So it's loading your cart with a certain items from the retail site, and then eventually using your credit card to pay, and then it ships off, right? So again, a good example of something that someone else, you don't have to write your own inbox and credit card modules and things like that. MageCart did that for you. So this was a popular subcomponent that organizations like British Airways, Ticketmaster, and Newegg used. So what they did here is they somehow got into the development lifecycle, pre-deployment or packaging up for the purposes of commercially selling the MageCart functionality out. And they did it wasn't even a modification, they did an add-on to a certain page. So that's what's shown, spinning it here. Obviously very difficult to read, but here's the source code behind this page. And everything at the top, above the red rectangular box here, was the normal functionality of the website. So what this website is doing is taking the user's credit card information and then sending it off to get validated for the purposes of the purchase to occur. Now, what's in the red box is what the attackers in this case somehow got added to the bottom of this page. And what it's doing is it's taking that same form input, including the credit card number and CVV and the names and whatnot, all those valuable pieces, and it's sending it off to their own server that's out there on the internet. I'm going to jump ahead one, but this is sort of that boxed piece exploded. So hopefully you can read this, and I'm not going to geek out on it too bad. But what it's doing here is taking, let's see, where is it? Yeah, it's like I said, it's taking the valuable information that the user has put into the form, and everything above it that happens going back on this page is the real deal. So that it's actually functioning, and you get your stuff 2 days later. But this got added to the bottom, and you can even see the URL in line 9. This is where it's sending that credit card information. This is a server and an address controlled by the attacker in this case. What's interesting, if you look at it, is it looks legit. I mean, it's Newegg stats, so this was obviously the attack on the Newegg site. So at a glance, even if you do a manual review, you see that. You even see it's HTTPS, so they went and got a certificate so that they could secure the site. It looks even more legit. But it's not. It's something that was controlled by them. There's a couple other examples like AA metrics and things like that. So these people made it look like it was legit for anyone. Even doing your pretty solid due diligence, you could probably get fooled by this. It looks benign, but it's really not. So this type of exploit, I think, shows up 1 or 2 more as I go down through the next 3 or 4 that we have, where it's kind of an attack on the life cycle, on the development life cycle. They're getting upstream within the development phase and getting changes done that get delivered out. This one is super simple and super sinister if you can pull it off. So again, we have websites all over the place that are housing third-party objects that people are using to build their software. In this case, this is called cyber squatting or typo squatting. So there was a package called Colorama, which, as I recall, it takes stuff in a shell or just like a DOS-looking screen, and you can add colors to the fonts. And that's all it does. It's a simple utility, so everything's not white on a black background. You can add your colors to it. So what these attackers did is, this one was called Colorama, which is, it's a it's a Python, yeah, it's a Python package called Colorama. They created one that was identical, except for some bad stuff they put into it, and they called it Colorama kind of in the British way you spell it. So they threw the U in, and then created a site that would do exactly what the real Colorama did. It would pull down all those packages. It would color your letters within your DOS box or whatever for you. Everything worked fine, but they then could, of course, add whatever else they wanted into that same set of functionality that's there to, actually in this case, they were doing, they were stealing Bitcoins through this particular, I don't know exactly how that piece of the thing, of the attack happened. But I mean, talk about as easy as it is. You're taking advantage of a typo or another. This is even a valid spelling of color. I mean, it's just if you're from Europe, at least. It's not used here as much, but there's other examples of this where you just get, you know, something that sounds right and recreate it. All right, I think this one's the last one. Yeah. So CodeCov. So CodeCov is a technology that tests out your code coverage when you run quality testing against an application. And it's a software as a service, so you actually send your source code up to CodeCov, they calculate this, and then you get reports and metrics and things like that back. So as part of it, when you deploy it within your software development lifecycle or your development pipelines or whatever, is they gave sample scripts that you could use to package things up and push them to their SaaS where the actual testing happened. So somewhere along the line, it actually had something to do with the way they did their Docker images. Attackers were able to make it so that they were sending pieces of your server to them versus straight up to the legit CodeCov SaaS offering. In this case, they were actually scraping environment variables off of the server, which sometimes have some private information or information that you don't want to get, or that can be used by bad guys. So they were just taking all the environment variables, sending those off to themselves, and then figuring out what to do with those to kind of do the next stage of the attack here. So that's kind of how that looks. So the line of code, or that was used here in many cases, is written down here at the bottom. So it was just, you can see without even unpacking this, that the environment in the middle, so they're pulling environment variables and they're sending them off to the IP address that's under the blue scrape box. So again, stealing valuable pieces and then figuring out how to take those and turn those into something that can do more damage. Okay. Then there's a few others. I listed them here that I've noticed. You've probably heard of SolarWinds. That was a big one. That was effectively similar to the Mage card attack, where somebody got into the development lifecycle upstream and managed to add a line of code to SolarWinds. That one was particularly nasty because SolarWinds is a network and IT management platform that was still is very much in use. So organizations that were using that capability, SolarWinds has inflated privileges usually because it's got to see all the nodes on your network and be able to manage them. And then those organizations were downloading the latest versions, and they had been exploited, they were both poisoned, and they were also past the code signing at the end, so it looked like a legit piece of the SolarWinds, even though it was doing bad things. We can move on from here. There's a few more if you wanted to look them up. If you've ever looked up exploits, you've probably seen what I've seen. It's a little bit difficult. Lots of them, the story goes, so-and-so was hacked. We found out on this date. Here's roughly what the damage was. We lost first names, last names, and social security numbers or something like that. And then it was like what the company's doing to alleviate that, which is usually getting you credit monitoring or something free for 2 years. But finding the details of what exactly happened under the hood takes some searching. So I did a lot of that and tried to boil things down to a few bullet points on what happened. So a lot of different ways that we're getting attacked or exploited. So what are we doing about it? So this is a kind of a combination of what I found through some research on what orgs are doing to understand and secure the risk within their supply chain, as well as some things that I see, in my job out in front of customers and things like that. So I bet most people here that have anything to do with development have heard of a SBOM, or a software bill of materials. That's been a very, very hot kind of a mandate / topic over the last year or two, probably 2 years or so. So I'm going to come back to that in just a few minutes. But in order to kind of understand, if you go back to the original slide around what exactly is supply chain, and it's all the pieces that are coming into your world when it comes from a development standpoint, we're going to want to manage the dependencies there, kind of the third-party pieces that are coming out, off of the internet or off of a subcontractor or off of somebody you hired, however it is. You're going to want to manage and understand those dependencies, where they came from, what their issues are. Vulnerabilities as well. So once we figure out there are problems within our application, be they supply chain related or not, we're going to manage those. We're going to understand our patch and version levels. That's very important in what we're doing here. We're going to have training here. So some of the things that really jump out at you quickly is, I talked earlier about, I think I used the term Wild West. If your developers are just going out to public sites and pulling the version of the software that they want, that causes problems right there. So training and teaching all your users or all your stakeholders how to do things safely. That type of training is a must here. So that I actually heard when I was talking to somebody in this space, they said that they would go talk to organizations and they would be convinced that, we have repos and all our people are using our own private repos. They're not pulling stuff off the internet. And then they could show, because they controlled the public repo themselves, that no, that's not the case. It was more like 80% of them were still going to the public repo, not the one in-house. So that's another example of why training is needed, so that users within the organization are doing things properly. Development process, and then the bottom one here on the left, continuous monitoring. This is not obviously like an atomic test of how everything is and then you move on. So this is something that needs to be repeated and kept up with and part of the day-to-day or week-to-week operations. As far as things that need to be secured, I've already touched on a lot of this. Source code obviously makes sense. We already saw a couple examples of bad actors getting into source code that gets checked back into the baseline and somehow makes it out into the field at some point. So obviously that's important. Repositories as well. Even if you do have everyone pulling from your secure repository, you need to make sure that people can't get into that and change the versions or change what's downloadable within that repo. So that everybody is in fact using the latest and greatest and safest artifacts within their development life cycles. Build pipeline, same kind of thing. You can't have people able to change your build script so they're pulling rogue elements into that particular build as it happens. Let's just jump ahead a few. So infrastructure as code. This is becoming more and more common. Another place where we're going to tax. So if you're spinning up, with the click of a mouse, we love cloud computing. You can spin up 6 servers that you need to have this whole enterprise thing going and running. It could be containerized or in cloud servers or even in regular servers, et cetera. But the backbone of at least the cloud and the Dockerized Kubernetes type of deployment is exactly what pieces get spun up in the manifest and how those all work and tie together. If someone can attack those, they can change those into malicious objects or server OSs or containers or whatever. And again, continuous monitoring applies here as well. So just a few of the themes that seem to be going out there, and a few of the ways that you can, or kind of questions and checkboxes you have to check off if you're doing this within your own organization, if you're looking at supply chain issues. Okay, software bill of materials. So this is Executive Order 14028, which came out 2 Mays ago. So this is about 2.5 years old already. So on improving nation cybersecurity. I think this came pretty close after the Log4j problem that we talked about. So the U.S. government issued a mandate that requires application developers that are selling to the public sector to include SBOMs with their software packages. Software bill of materials. In the very next slide, we go into a little deeper of what that entails. There's a few mainstream formats out there already. Cyclone DX is one I see the most, but there's a couple other ones as well. So these are file formats where the information of the SBOM, where you post it in there, they're usually like JSON or XML, some kind of a standard format. So those get packaged in there. It makes it easy to load them into other machines and other databases and capabilities if you wanted to view them or take advantage of them. So what exactly is in an SBOM? So a bill of materials to me is usually just what you're buying lots of times, right? We're selling software, say, and we get someone on the hook to buy 3 licenses. So what exactly are you buying? In the case of software supply chain, it's a little bit more sophisticated in that it's not only the what, but then it drills down from there. So what's up on the screen here is the left side are the high-level components. This is actually specifically Cyclone DX. But this information is valuable to you guys that are, if you're working in this industry, to make decisions about what objects are acceptable to use and not use. So the left side is kind of some high-level information, exactly are the components, what license model does it use, or licensing, what license type, does it use? Open source and everything has its own license and they have different effects downstream for those. What makes up those objects, what dependencies those objects have, and maybe even dependencies those dependencies have. So some of these will drill down even further. But within the vulnerabilities, which is usually the one we're most interested in, at least from securing the supply chain, is these items down here on the right. So these are details about vulnerabilities, plural, that often can exist within this particular object. Yes, we have a question.
The previous slide said that this executive order applies for selling to the public sector. What about selling to the government?
The government sector? Oh, that's what I meant by public. No, that is, it applies to the government, yes. Did I say that wrong?
Anything before, like, the DoD, for example,
Yeah.
would already have that ability in there?
It should, yes. Yep. That's what the mandate calls for within that executive order, with a bunch of legalese in and around it. So I tried to make it as accurate as I could, not being a lawyer. Yeah. Yep. Yeah, this one is specific to selling into the DoD, the IC, the U.S. federal government. One of the other ones that's listed further down, I don't go into them, is it includes the U.S. industrial base as well, so the commercial side of the world. Thank you for telling me to clean that up. Okay. So within what's going over here on the right, you're going to get some deeper information about those vulnerabilities. So it's not just, yes, we have a Java deserialization flaw in this particular version of this particular library. There's a lot more detail that hopefully is in there, like exploitability, how easy it is to exploit, how critical it is, what type of problem it is. We have things like risk rating, evidence, which versions all exist there as well. So that stuff all gets packed in. So they're not just getting a listing of all the external stuff that we're using within this application. We're also getting detailed information about anything from a security problem as well as a license problem as well. That comes all as part of that SBOM. Okay, so I'm going to kind of quickly go through, what time we got? Yep, we've got about 24 more minutes. So looking at some technologies that can help you get your arms around this data back here within, creating your SBOMs, as well as just in general, make it so you guys are, or your guys' organizations are creating and deploying more secure and legally okay applications or programs and things. So there's some technologies out there. I'm talking technology and product and capability level here. We're not talking about any specific vendors or anything like that. This is an AVCIA show, and that's how we do it, which I'm totally for. But we do at least have some acronyms about these capabilities out there. So there's static application security testing, which is testing source code directly for vulnerability issues. Software composition analysis, which is looking at those third-party libraries we spent a lot of time talking about already, seeing what their flaws are, then reporting those back to the user. Dynamic application security testing, which is another way of testing software. In this case, you're testing running software, again, for security flaws as well. We're going to come to OS shortly. And then there's a few other ones that can be used: penetration testing, interactive application security testing. But I'm going to focus more on the first two or three or four, I mean. So static application security testing, in this case, we're looking at, it predominantly focuses on source code, but the libraries that are used by that source code, so by source code, I'm talking custom code usually. But the libraries used by that custom code come into play, at least peripherally here as well. So this is definitely a capability that organizations that are producing software should be doing. And I think I mentioned earlier, it's drilling through the custom source code, scanning through it, and finding usually developer mistakes or oversights that cause vulnerabilities within the code. So we can, organizations that have this type of capability can not only show you, look, I found a SQL injection, but they can show you where it is and why or how it's a problem, as well as what to do about it. So that's a key piece of cleaning up your supply chain. This more focuses on your developers and subcontractors and things like that, as far as, are they giving you, code that does not have problems in it. Software composition analysis. So this acronym and this capability is relatively new, because a lot of these organizations that do this got their start focusing on licensing, particularly open source licensing. If anyone's used open source, you got to check the license, because you might wind up tying it into your application you're creating, and the license says the second you do that, then your code becomes open source as well. There's stuff like that going on there. So that's an important piece, but of late, these organizations are pivoting, and they're doing that plus vulnerability finding within those DLLs as well. The way it works is it scans, and let's say it finds Hibernate version 4.236. So it can do a hash of that, match it up, and say, okay, that is in fact Hibernate 4.2.6. So we know exactly what it is. And then that particular capability can look out into the public sector, into the database of the common vulnerabilities, the CVEs, other publicly available stashes of known vulnerabilities out there against objects, libraries, applications, and they match those up and then report it back. Usually the remediation advice, hopefully, is you're on version 4.2. If you upgrade to version 5.3, then that problem goes away. So that's really what what software composition analysis is from a testing and analytics purpose here. So it doesn't actually scan through source code or scan through the library itself. It takes advantage of what's out there, that we know there's these flaws in these certain versions of these certain libraries. Some of the more enterprise companies that are doing this also have their own security team, so they might even have findings or stuff that they can kick out as far as their findings within that. I'm sorry, hang on. They can report against their own risk intelligence that they created as well. So that's, if you're talking to organizations that do this, those are good questions to ask them if they have their own security research team or where they get their back-end risk data. There's often, you'll find it again in some of the bigger, more enterprise organizations, the bottom number 4, they might even have add-on capabilities that aren't just doing the testing and reporting back to you what the issues are and even the management console on that, but they might have their own repos they can sell you or ways to keep flawed things out of your whole development environment, period. Like, think of it as kind of like a firewall, where if you try to pull down something that is known to have issues, it won't pull down, for instance. So there's other kind of sub capabilities within this space that you can look at and take advantage of there. I just have a couple generic screenshots here that kind of display some of the data that you'll see as a user. And behind this is that SBOM. So this is all that same information you see on the screen here makes its way into the SBOM. So on the left here we can see, or I'm sorry, right in the center, the name of the file over here on the left side, what the priority of the finding is, evidence if there is any, whether or not the application invoked it. That can be in there as well. That's pretty important because you might find findings, but if you're not using the flawed part of the library, it's at least a lesser priority that you can focus on the ones that are really causing the immediate issues. Mapping it over to the CVE, so this one had a CVE of 2020-9521, what the category of finding was. This one had a SQL injection, et cetera. So this is a human readable view, but if you can think behind this is an SBOM that might be part of your deployment package or, I'm sorry, push to your ATO or whatever. Let's go very quickly through here. Yes, sir.
Are there any frameworks on like risk-benefit analysis of writing your own code versus going externally? Because everything external is safe until it's too late.
Yeah.
So how do you balance, growing your own or going open source?
That's a hard question. I should know that. He's a sales rep that I work with all the time. All right, now, great question, and thank you for filling in the answer. Comes back to metrics all the time, right? Okay, here's just a real quick, this is just what an actionable result would look like. So in this case, we found a flawed library that we know has an issue. The little blue dot in the graph on the right side is the version that this particular organization has in the software that was just scanned for these problems. And then we can, in this case, we're seeing which versions to the right, the newer versions are listed, and which ones fix the flaw. And sometimes you might even have this particular capability has a popularity metric there on the top as well. So you can at a glance say, well, a bunch of people are using the one on the far right because of the big green bar. We should do that as well. Sometimes you probably want to go usually with the most popular one, or at least that should be some criteria. There's a reason it's the most popular. Okay. So another capability here, this one's a little bit more peripheral than the first two that we already talked about, dynamic application security testing. So this is doing security testing, but against a running server, which is usually a website. It can also be APIs in some case, depending on who the provider of the software is or the capability is. But it finds problems within the source code by launching attacks and probes at it and then seeing what comes back. Specifically, oftentimes it can ask for information from the server and give, this is Tomcat version 8, blah, blah, blah. So it could pull some information about the underlying capabilities that then might cause a supply chain issue as well. So they can find it in a couple ways by finding actual vulnerabilities in the app itself, as well as some of the peripheral information about the building blocks that are in the server, in the software too. All right, I'm going to skip that one. All right. Okay, so cool. We got just two more, and then we can open up to more general Q&A. So we've already talked about the middle executive order here, 14028. And as I pointed out before, it directly calls out software supply chain, as well as SBOM. But we also had two other ones. The top one is about, this is what I mentioned earlier in response to the question, that that one's about across both industry and government, about strengthening the resiliency of U.S. supply chains. If I recall, these really just asked for guidance from some sub-organizations to actually drill into it. But it was becoming more and more mainstream to have these problems back in early 2021. And then the last one is a little bit similar as well. Strengthen supply chains with sectors of the information communications technology and industrial base. So this one was calling about not just the federal government, but the commercial space as well. Okay, so to wrap it up, we talked a little bit about a lot of this, but these are some of the key kind of takeaways that you think about if you're building or executing or becoming concerned about supply chain management. Have a process and a policy. That's pretty obvious and pretty fine, but you know where developers can go to get their open source and maybe how they provision things. You know, whatever the processes are in and around that, what's acceptable thresholds, all that stuff when it comes to process and policy. Address the problem early in the development life cycles. One of the problems with third-party libraries, particularly open source, is they're not necessarily backwards compatible. So if you fall too far behind in these, you know, these newer versions or fixing problems are being discovered, it's not just as much as, oh, I had 3.1, I'll download 3.7 and the problem goes away. It might break your app because it does, like I said, it's not necessarily backwards compatible. So that's why it's important to keep up early and often so that you're just doing minor tweaks to, hopefully, to your software that you're developing versus having to do everything at the end and jump 12 minor versions at once. I already talked a lot about continuous monitoring and testing, training we've talked about. Take advantage of some of the supporting technologies, static analysis, dynamic analysis, software composition analysis, testing and scanning your libraries, your third-party pieces of your code. It's probably pretty important to, this ties into policy as well as technology, have some kind of a way so that you're pulling the versions of the software that your organization wants and keeping that consistent. The last one, AI-generated code. So this was something I just wanted to kind of bring up because anyone who was in yesterday's keynote luncheon, this came up. It wasn't in the slide deck 24 hours ago, but it is now. So not just the government, who's the DoD CTO, said that the DoD is looking at using AI to create source code that eventually makes its way into production. So you put that in the context of software supply chain management, particularly around securities, it's at least a brand new vector, right? I mean, it's not open source, it's not a human that made it, it's not my subcontractor that made it, didn't necessarily come from China or somewhere. You know, it came from AI. And I mean, we could sit in here for an hour and probably come up with enough questions here to say that pops up a whole lot of stuff. So I think maybe by next year, there'll probably be a few presentations on this exact thing and what it means for the world once we know what to ask and maybe how to answer it. I mean, I'm not an AI guru, but I think they develop bias and can get off track. I mean, who knows what could happen. It kind of scares me, actually. If anyone has any thoughts of that, raise your hand and you can fire away. Okay. Yep.
So aside from the AI-generated code, which could have bias or some implicit flaws in it based on the training data, do you know of any ways of using AI or machine learning to do a better job of detecting flaws in code? Tools for auditors?
Yeah, I know there's some AI that's being built into some of the technology I went over already where we're running straight up tests against software applications that are running or not running static or dynamic analysis. One way that machine learning can, and in some cases is really helping, is if anyone's done particularly static analysis around security vulnerabilities, you know it can be really noisy, right? It's designed that way. The assumption is if there's a problem and it looks like it's not really that much of a problem, I'd rather a human make that decision versus having your testing technology just ignore that finding. But that makes it so there's often a review process that's involved in getting from 1,000 findings down to the 200 that really matter, that need to be fixed before you deploy. We know of organizations, including our own, that are doing AI and machine learning within that, call it the triage process. And it will learn over time. If it looks through 10 SQL injections, and it'll say things like, yeah, I'm 85% certain this is in fact exploitable. But then a human can come in after the fact and say, no, it's not. And then over time, that's where the machine learning comes in. So over time, that model or that AI capability gets more and more sophisticated, more and more accurate. Same as general AI. I mean, that's a training, training purposes there as well. But that capability does exist is within that testing lifecycle. So hopefully that answered it. Yeah.
Is there any DoD requirement or common requirement that you know of that's relative to where your code is developed?
Not that I've heard of. Is anyone else?
What was the question?
I should repeat it. You're right. Is there any kind of government mandate or policy or anything coming down the pike that mandates where, or I guess listens to or mandates where your software is created geographically? Yeah.
Aren't there some restrictions in the government that says they can only use code that is compiled?
Built in the U.S.?
Yes,
That's part of the DISA app stick, right? I think.
There's also compliances in terms of where code is developed in sectors.
Okay.
Developed it in another location, it cannot link to another
Okay. Okay. Perfect. Yeah, thank you. Did you guys hear that answer? Okay. Yeah.
different topic though. What activity and momentum are you seeing in CMMC adoption? You guys are involved with it. That's
Yeah. I personally am seeing very little still. I mean, we've done, yeah, my company, I work for a very specific piece of it from a product set, but my company has hundreds of applications. We've done mappings into CMMC across our entire portfolio, but I personally am not seeing much adoption or organizations that are taking advantage of that or using that or doing their high-level enterprise decision-making. Yeah. Right, so. Yeah. Yeah, that was the point. And I don't know, has anyone else seen that takeoff or using the CMMC? Cyber maturity model? All right, I got time for one more. I'll do you.
So on the SBOM you laid out there, I'm assuming it's a software developer organization that creates it because it uses a number of tools to create pieces of information.
Mhm.
But it showed that it had vulnerabilities listed. So there's the assumption that as long as you list the vulnerabilities in your SBOM, it's acceptable.
Yes and no. I mean, yeah, you're right. That's the requirement, right? But if it's just full of exploits, I imagine, I mean, you're getting down to a lower level of decision making at that point. It's like what's acceptable to the security officer or the security decision maker at that point.
What puts the onus on the consumer at the DoD to make sure they're reading the SBOM and say, oh,
Yeah, right. Yeah, I mean, it makes sense, and I'm sure this is happening now where organizations are putting acceptable criteria of what's in your SBOM before you deploy, or I'm sorry, before you deliver to them. But for now, it's a relatively new concept. I'm not sure if anyone's doing that quite yet. But Yeah.
Otherwise, it all depends on the organization and the risk process.
Right.
Yeah, the software is just part of the ecosystem. It's other controls.
Right.
All it might be in the software exposed in the environment.
Correct. All right, one more.
So, we all understand the value and the importance of finding these vulnerabilities as early as possible in the software development lifecycle. Is there an approach that you experience where that information gets back into the organization's process to remediate? I mean, it's one thing to say I found 1,000 vulnerabilities and these 200 have to be addressed. What happens then?
Yeah. Yeah, exactly. So, I mean, that goes to where software development is going to today, where you guys have all heard continuous integration or DevOps, DevSecOps, even continuous delivery. So those are all in kind of similar in a way, but they also are feedback loops. So for years we've been saying shift left is the best thing to do when it comes to testing. You know, test early and often within your development life cycle. We're starting to hear the phrase shift everywhere because of the cycles, and there's testing going on at various pieces of the life. Yeah, you're shifting all over the place. Exactly. So those pipelines are sometimes have automated criteria in them, whether they pass or fail and move on to the next step of the development process, or if they have enough problems that they kind of get rejected or kicked back, or that maybe the whole check-in of that software fails in many cases. So all this automation is taking care of a lot of that for you. And it helps the developer because in the traditional standpoint, if they made a mistake and it caused a problem, even in Agile, you're talking about weeks probably before that developer sees that thing kicked back to their desk. And then they have to think about what they were thinking at that time and why the mistake was a problem. Where nowadays with those more advanced, even daily or hourly cycles, these issues are released fresher in their mind, and it's much quicker. And it makes it so you don't make the same mistake again ever, or for at least for the next 3 weeks, if you're in kind of a 2 to 3 week agile process. Great question. I'll stick around for a little bit. We're at our hour. If anyone wants to come up and ask some more questions or have a discussion, but thank you all for being here.